and he's taking
The recording. All right, welcome to our last day of chemistry class. We're going to review for our test tomorrow. We're going to have a review game that's very at-home learner friendly, so the at-home kids will be able to participate with us. A little more at-home friendly than the Kahoot was, and then we'll have a review and a test tomorrow. So this is going to kind of be it. So this is one of my favorite days. This demonstration right here is one of my favorite demonstrations. We'll do it last. So it's so cool. It's such a magic trick. So, okay. So what makes an acid an acid? Let's review from yesterday. Jane, what makes an acid an acid?
The positive thingies.
The positive thingies. Brooklyn, you want to give us a few more details?
Aren't they H3O?
Okay, so it's either H3O plus, or you could call it H plus. Okay, this little H joins up with waters, and then it unjoins with waters, and it joins up with waters, and it unjoins with waters, and it's kind of swimming around there in the solutions. I usually just call it H plus because I'm kind of lazy that way. But be aware that it does join up with the H3O plus. So what makes something a base? Bree?
OH minus.
OH minus makes it a base. So what if I make a chemical equation out of this, and I have an H plus an OH minus? What do I get?
Neutral.
A neutral, but what molecule do I get? Water. Look, I have two H's. I have one O. It totally makes water. Totally makes water. Okay.
So then water doesn't have something?
Water doesn't. You gotta be loud, Bree.
Water doesn't have a pH level then?
What's
Water's
the pH
neutral.
of water?
Seven.
Water's
neutral.
neutral.
Okay.
Pure water is neutral. The water that
Neural.
neural. We have neural water. It helps you.
It's very smart. Very smart.
Look, you could just stick a tea in there without even trying. That was a beautiful thing. So water's neutral. Water doesn't have pure water doesn't have, it's neither acidic nor basic. Is everything acidic or basic? No. If you dump a bunch, let's say you've got a bunch of H2O in here, right? H2O. Okay, you got a bunch of water in here. And I dump in a bunch of salt. What am I going to have floating around in there?
Salt.
Ions. I was hoping you could tell me specifically which ions I'd have floating around.
Negative and positive.
But what are their names?
Chlorine ion.
Chlorine. It's not Bill and Susan.
Sodium.
So I'll have a bunch of
Sodium.
chlorine ions, and I'll have a bunch of sodium ions.
It's purple. That's a beautiful shade of purple.
Isn't this a nice shade of purple? Okay, there'll be a couple more than that. Is it an acid or a base? Is this acidic? Do I have extra H plus ions floating around? No, so is it acidic?
No.
Do I have extra OH minus ions floating around?
No.
So is it basic?
No.
Does everything have to be an acid or a base?
No.
No, not everything is an acid or a base. This is one that's not an acid or a base, okay? So not everything. Water is completely neutral. Our water that comes out of our taps has a lot of calcium in it, and calcium will make it basic. Calcium hydroxide, CaOH, is a thing, and it is basic. And so I actually have to use distilled water to mix up our universal indicator solution, because if I use tap water to do it, it will be blue, bluishy green. Yeah.
So what is in universal indicator solution? What's the chemical?
There are actually several chemicals in there, and I can't tell them to you off the top of my head. But there's multiple. There's a chemical in there that turns red when it's acidic, and there's a chemical in there that turns blue when it's basic. So there's a couple. Yeah.
I was why is the water like when I put it in hot water it's like
That's bubbles.
oh
When you pour a bunch of hot water in, remember the gases aren't very well dissolved in hot water, and so you can see those bubbles and they're coming out of the solution. But when you pour water in, it's gonna grab air while it pours in. So that's
why it
water.
looks like it's really dirty or something.
That's why when you pour, have you guys ever done that where you like a bunch of water into a cup and it looks like it's like white almost? That's just dissolved gases and they'll come out and it'll clear up. So Chad looks concerned. Have you never had this experience? Oh, we could do it here. Like we could like this is not even a hard thing. You just fill up a cup of hot water and it's murky. And then it clears and then it's just bubbles. Okay. So we squirreled there for a second. So if I have an acid and I add a base to it, what do I get?
Neutral.
Water, which is a neutral, okay? So let's say, I'm gonna make my jug bigger. Let's say I have a really big bucket of water here, okay? And I'm not gonna draw the waters. But I am going to I add a bunch of citric acid to it. So I have a bunch of H plus ions kicking around, right? What's this going to be?
Acidic.
It's going to be acidic, right? Because there's a whole bunch of H pluses. It's going to be quite acidic, isn't it? Because there's a lot of H plus. The more H plus you have, the higher the concentration, the more acidic it's going to be. So what if I pour in some sodium carbonate? Okay. And that gives, I put in three OH minuses.
Oh.
Is this solution going to be acidic or basic?
Acidic.
Why?
Because there's more H pluses.
There's still more H plus. Now, this one and this one, they're going to hook up
Make water.
to make water. And this one and this one are going to do the same thing. And this one and this one are going to do the same thing. Here's a question though. Is it as acidic as it was before?
No.
Which direction did the pH go?
Basic.
Down.
Right.
Up.
It went up. So if the pH was like 2 before, it's going to be like 4 or 5 now, right?
Yeah.
The higher the acidity, the lower the pH. It's because it's a logarithmic function.
That makes sense.
Okay. Do you want me to melt your brains for a second here?
Yeah. Down to one brain.
If pH is the measurement of the concentration of H plus ions, what do you think POH is?
The concentration of OH.
It's the concentration of OHs. So if it's more basic, what will the POH be? Low. And if it's more acidic, what will the POH be? High. So why do we just use pH?
Because it's simpler.
Because it's simpler. But you can use POH. That will pretty much only help you on quiz games. That won't be on a test or a quiz. It was kind of just a gee whiz, but it's kind of interesting, isn't it? So what if I want this to be completely neutral? What do I need to do? Bree.
Add 2 more OH minuses.
Okay, so last time I added 3. If I add as much as I added last time, it'll be too much, right?
Mm-hmm.
So I need to scale myself back. Add an OH here and an OH here. Now, wait, what do we, okay, so this OH is clear up here and this H plus is clear down here. How do we solve this problem?
Move
Mix.
them.
We stir it. This is why we stir. Did you guys notice yesterday? You'd have you'd have your stuff, right? Like here's your cup.
And your
And it'd be
little
dark
thing.
and then it would turn light.
And then,
Yeah.
yeah, and so maybe it's acidic. And if you add some stuff, it'll be like purple,
They said only in like one spot.
but only in the middle. And then you stir it and the whole thing becomes like blue or green, right? That's why, is because this guy needs to find this guy and we need to help them get together. If we just let it sit there, would they get together eventually?
Yeah.
Yeah, because molecules are bebopping around, but we don't have that kind of patience.
Well, if that was to scale and like the hydrogen was on the bottom and the OH was at the top, I would think it would.
They would. They'd get together eventually. They're moving
If
around.
that was to scale, though, this would be some very
That's
big
a small
molecules.
Yeah, this is a teeny tiny little cup if you think about it. If it's to scale, it's not. Do I need to write?
That's
I'm
like a
not to
cup
scale?
that's like
Or the
Yes, it's
molecules
somebody just
are
said
giant.
that.
It's like a little.
Not to scale.
Why'd have to write all that? Why not just make it to scale?
Well, because I am limited by the ability for you to be able to see the OHs. Because the real H2Os and OHs are smaller than light waves, and so light waves can't bounce off of them. So I need to make them big enough for us to see, but also still fit on my board. So I have to make it not to scale. So let's get these guys together. I'm going to stir it. This H plus, because this OH minus is an H2O. This H plus, because this OH minus is
H2O.
H2O. I should have made the H2Os
Wait,
green
Mrs.
because green
Barlow.
is neutral. Yeah.
Does that mean that you could drink it and it would taste like water?
Whoa.
Okay, so there are other chemicals hooked on. Your citric acid. Do you guys remember what this formula for citric acid is? I don't off the top of my head.
Yeah.
There was something in it. It was like
Really?
There's something else.
I think it was C something, H something.
You know what? Let's take hydrochloric acid. Because I know that formula. HCl. And
Wait,
then
no,
let's say we have sodium hydroxide. It's also a strong base.
I know the thing.
What is that going to become?
Something dangerous.
So the sodium
salt.
hydroxide dissociates in water.
Salt and water.
You get NaCl plus H2O.
Salt water.
You're totally going to taste that NaCl.
So you could still drink it. 'Cause
You
it's
could
salt
drink
and
it.
water.
This particular one you could drink. But like if you have like HF,
That's gonna go.
That's good.
that F is still going to try to destroy all of your cells and bond with all of the calcium in your bones, and it will still hurt you. So even though the H2O part is taken care of, you still have this fluorine that is going to be very, very dangerous.
Oh.
So breathe.
Citric acid is C6H8O7.
C6H8O7. So you're still going to have like the carbon and the oxygen. It's probably going to make some carbon dioxide. But you have other things coming along. We're not just
Is
dumping
that why
in.
there was bubbles?
That's why there was bubbles. It's because it made carbon dioxide when it reacted.
Whoa.
So I want to scroll for a moment and talk about, I've talked to you guys about the professor at the University of Utah who spilled hydrofluoric acid on his fingers, right? One thing I didn't mention is that the hydrofluoric acid was hot.
Oh.
Do you think it mattered that the hydrofluoric acid was hot?
Yeah.
Why?
Molecules are
Is it-
moving faster.
The molecules are moving faster and the chemical reactions happen faster.
Yeah.
So do acid-base reactions also happen faster if they're hotter?
Yeah.
Probably.
Yeah, because they're chemical reactions. Okay.
And they're moving faster.
So we're gonna play with this though. We are gonna play with this a little bit here. Now, one thing I want you guys to do, one problem we ran into yesterday when we were mixing up our citric acid solution, it was like crazy freakishly concentrated and like we couldn't do much with it. I want you to mix it up a little bit weak today. Just add a little bit extra water, okay?
Or like a
So that way
single
we have to-
grain.
Or like a single grain of the citric acid, something,
Like
but
two
it's just,
sodium carbonate.
it's just so much. Okay. So So I've got some universal indicator solution here. You can see it in front. What color is it?
Green.
Why is it green?
Cause it's
your
neutral.
favorite color.
Because it's my favorite color. Actually, because it's neutral. I need to put my glasses on.
Breaking the
Safety
law.
first. So
You know you actually can't see the eyelashes on camera.
I know you can't see the eyelashes. If I get really, really close.
Maybe it just looks like
For those
really
of you
bushy
at home,
eyebrows.
I have beautiful eyelashes on my
Mrs.
glasses.
Barlow, they might see it as like bushy eyebrows.
They actually probably do. It's not eyebrows. It's eyelashes. Okay. So poor Sophie. She's probably like, wow.
Beautiful.
All right. So what is going to happen if I put some citric acid in my universal indicator solution?
It's gonna become
Red.
Red.
It's going to be red. I'm going to add
Red.
like 3 drops.
Red.
1,
Red.
2, 3.
It's gonna be like yellow
And I'm
then.
going to swirl.
Whoa.
Yellow.
Oh, it's like not even like, okay, so it's a slightly lighter green.
It's kind of yellow.
It's kind of a yellowy green. I would say it's probably at a pH of like 5. Let's maybe add some more. I diluted my citric acid solution because it was a little excited.
Yellow.
1,
Yellow.
2, 3. Oh, now if you
That was
look,
4.
That was four.
that was 4. It's
Look at
red
the bottom.
in the. You can't see.
I can see it.
I can see it at the bottom of the cup.
It's red like in the middle. I'm trying so hard. I'm going to show the people in real life. Can you see how it's like red where I haven't
Yeah.
stirred it?
Oh, if you look at it through
It's
the
at the
light.
bottom. It's
Look
really.
at it at the bottom.
No,
that's kind of spreading.
It looks like food dye. but it's not.
Oh, that's a great shot. You guys see it?
That's a great
How it's
shot.
like red. in
Take a
there?
picture.
Great
Take a
shot.
picture. It lasts
Yeah,
longer.
we're gonna take a picture of it. All right, now I'm gonna swirl it. Woo! Swirl,
It's
swirl.
yellow.
No.
Light green.
Light green. I'm gonna add more.
Then it'll be yellow.
1, 2, 3, 4, 5. Ooh,
Okay.
you can totally see the red taking over in there. Swirl. Oh, now we're red.
Oh.
It's like orange.
We're orange. We have a pH of like
Oh.
3.
3, and I'm at peace with that. Okay. So, how do I make it back to green?
You add
Add
base.
I add a base to it. I add the sodium carbonate, and it'll go back to green.
That's neat.
I might have to
We
use
should
a
do
lot.
that in our-
I did make my citric acid solution significantly less concentrated than yesterday. So let's count. 1, 2, 3, 4, 5. Now, if you look,
What?
there's
Whoa.
inky purple.
Inky purple.
But it's never as strong as it seems it would be.
See, it's like inky purple back there.
It's like
You guys. Oh, now it's turning green. It was purple for a second. Now it's blue.
It's green.
Ooh, I just kicked it up, and it's like rising to the occasion.
rising.
That is so cool. I've got to tell you guys, universal indicator is like one of my favorite things in the world. Okay, I'm gonna swirl it.
It's wonderful for us too.
Oh, it is green. Oh, that happened quickly.
Yeah.
Yeah.
It's still too light.
It's
but-
still a little bit yellowy. I'm gonna add 1 more drop.
Oh.
1 drop more.
Lemons.
Yeah.
Yeah.
1 drop.
It's not really.
That didn't
changing.
change.
All right, 2 drops. I mean, you know, if you don't do it in 1 drop, do it in 2.
3 drops.
We have chirpy crickets again. How delightful. Okay.
I really.
Oh, that's a lovely shade of green.
But it's not
like
green.
emeraldy.
It's like emeraldy. I think we need 1 more.
Emerald better than light.
Cali green is the best of the greens.
Mix. I like forest.
There we go. That's about where we started. If we have our
Little bit.
control, we've got our control.
That's a lot
It-
darker.
Yeah, it's a lot darker.
Oh, you guys.
Close.
And add 1 more.
2 more.
7 more.
1 more.
16 more.
17. I think you need 1 more.
When I was practicing this, my kept adding too much more and then it would turn to blue.
Oh.
So, I mean, that's why I'm going like one drop at a time because I have trust issues.
Hmm.
One.
Yeah.
Okay, that's good.
All right. That's
Anybody-
pretty good. It's
Think we're about where we were
pretty
before.
Yeah.
Now, if I added more red, could I go back red?
good. Yeah.
And then I add more, if I added more acid, would I go back red?
Yeah.
And then I add more sodium carbonate, would I go back green?
Yeah.
Could I go purple?
Yeah.
Could I go back red from being purple?
Yeah.
Because we're just adding more.
It's still-
And then we make water, and then we add more, and then we make water, and then we add, and you can swing back and forth. So here's a question. Is the turning colors of the universal indicator solution a reversible reaction?
Yeah.
Yes, it is. It is a reversible reaction because you get some of the other one and it reverses back to the other way. Some chemical reactions are reversible, some chemical reactions are not, but this is one that is reversible. Isn't that cool?
Yeah.
Now I want you guys to notice something. I'm going to erase this so that we can kind of focus. We know that mass is conserved, right?
Mhm.
So if you have two hydrogens over here, you're going to have two hydrogens over here. If you have one oxygen over here, you're going to have one oxygen over here. But you know what else is conserved? Charge.
Ooh.
Charge is conserved in a properly balanced chemical reaction. I have a positive and a negative.
Is that
What does a positive plus a negative make?
Neutral.
Neutral. What do I have over here?
Neutral.
Neutral. Yes,
Is
free.
that why it becomes H3O plus when it mixes with water?
Well, because this is an H
Yeah.
plus and it doesn't bring any electrons with it, so it'll be positive. So it'll bring its positive charge. So yeah. So we could have H3O plus OH minus leads to H2O. But then is it one H2O?
Two.
It's two H2Os because we have four hydrogens, so we
And
need
two
four hydrogens, and we have two oxygens, and so we need two oxygens. Okay.
That's me.
So the atoms balance, but the charges balance too. Kind of cool, huh? Yeah.
So if you had H3O plus 2H or 2OH minus, you would have a negative charge.
Yeah, we have what we'd have is 2OH minus. We'd have an H2O. We'd have two H2Os over here plus this random OH minus. So this is what's
So
happening.
it would be basic.
So it would be basic because we didn't add enough acid to counteract. Oh, we still have this guy hanging out over here. We need one more of these guys to make him go away.
Mm.
But see, if we look over here, we have a charge of +1 minus 2. What's +1 minus 2?
-1.
-1. Thank you, Bree. I'm like, oh guys, come on. Like we can do math with negatives. I know we can. And then over here we have a charge of -1 because this one's neutral and this is -1. So remember when you said, when am I ever going to use adding and subtracting of negatives? There you go.
Oh.
We're adding and
Yeah.
subtracting negatives, right?
Can we do the straw thing
Can
now?
we do the straw thing now? Yeah. I want to preface this by saying that I did brush my teeth this morning.
Good. I don't know what
That's
that-
really random.
Despite the fact that I brushed my teeth, I have some pretty nasty acid breath going on. To demonstrate my nasty, nasty acid breath, I'm going to show you.
Great.
You're gonna drink it.
It's turning yellow.
She's drinking it.
What?
Wow.
What? That's illegal.
Oh.
You're still going?
It's gonna die.
Can we pause and appreciate my lung capacity?
Yeah. It's kind of gross.
Wait, that means it could melt You could breathe on someone and they die.
Let's all pause for a moment and be grateful that I wear a mask every day. So, what the what? I brushed my teeth. I promise. I did eat some pancakes after I brushed my teeth. But I brushed.
Pancakes are
You're
acidic.
My pancakes are not acidic, actually. I mean, I do put baking
Is your
powder in them.
toothpaste acidic?
My toothpaste has
It'd probably
No.
be basic.
I think I might know a little bit.
what?
Is it because your saliva is acidic?
My saliva.
Oh, it's. Mm.
I didn't spit in here.
'Cause
I'm not over here going. I didn't do that. What? What's going on?
Is the air acidic?
Is the air acidic?
Wait.
Is it?
What did I exhale? What do humans
Carbon
exhale?
dioxide.
I exhale.
Carbon dioxide's acidic?
Carbon dioxide. Well, guess what? Carbon dioxide does when you have CO2. When you put CO2 with H2O, you get. Oh, I can't remember the formula. All of a sudden.
Haven't we done this before?
H2
Oh.
CO3. Oh, I don't even have to do any balancing. Look at that. It already comes pre-balanced. What in blue blazes is H2CO3?
It's hydro.
Would it be
CO3.
Hydrochloric acid.
Nope, hydrochloric acid is HCl.
Hydrocarbonate.
Hydrocarbonate. Ooh, you're thinking.
Carbonate.
Carbon hydrogen. Carbonic hydrogen.
Carbonic.
Carbonic acid.
Carbonic.
When you put carbon dioxide in water, you get carbonic acid. So I exhale carbon dioxide. Everybody does. It doesn't matter whether or not you brushed your teeth this morning. You're going to exhale carbon dioxide because carbon dioxide is a byproduct of cellular respiration. When your cells use energy and they use oxygen, they produce carbon dioxide and your blood takes it to your lungs and your lungs get rid of it, okay? Which my lungs do rather effectively, okay? So, and it goes in this liquid and it makes it acidic. Now, do you remember when we had the club soda last time and we all commented on how nasty club soda is?
Yeah.
Why is club soda nasty? Because it's acidic because of the carbonic acid.
Yeah.
How many of you have been to Soda Springs and tasted the water at Soda Springs? Why is it terrible?
It's disgusting. You have problems.
It's horrible, Chad.
You thought
Chad.
it was fine. It was disgusting.
Okay, Chad has his own. I drink like unsweetened chocolate, so
You drink unsweetened chocolate.
I actually do. So I'm a special level of gross myself. But even I thought I drink unsweetened chocolate, and I thought that the stuff at Soda Springs is gross. It's because of the carbonic acid in it. Okay, so let's talk about this because it is actually a big deal. It's a big deal and it has environmental implications. So let's say I have a manufacturing facility in Idaho. Why did I choose Idaho?
Because
Idaho is the best.
Because I live in Idaho. And Idaho's in the western part of the US. So we're burning.
Are we now? Whoa.
We're burning something. We're burning hydrocarbons, whether it's coal, gas, methane.
Ooh, methane.
We're burning something to make our potatoes.
Potato. Wait. What?
What? This is a potato
Why?
chip factory.
Oh, okay. I'm like, we're just burning potatoes.
Okay. We gotta heat up the potatoes. We're heating them with
Those
gas.
are cute little
When we
potatoes.
Aw,
Okay, so
not just spelled.
what does the combustion of hydrocarbons produce? It produces two things. burning methane. So it's CH4 plus O2, and what do we get out the other end?
H2O.
We get water.
CO2
Yeah, say it
and
loud.
water.
CO2 and water.
Wait, but it's not balanced.
Yes, it is.
You need
No, it's not. You need
Yes, it
3 O2.
There, balance. No, wait, no.
No.
Yeah, that's right. That's
Yeah,
right.
Yeah,
it's good.
now it's balanced. Okay, we balanced it. They can't see the
yeah.
balancing at home. Sorry, people. I try so hard. Mrs. Barlow tries hard. So what happens is you've got a bunch of CO2 going up into the atmosphere. And the CO2 goes into a cloud with all of its other water buddies, right? What happens when you have CO2 combining with water? What do you get?
Methane.
CO2 plus water is what? Carbonic acid.
Oh.
Carbonic acid,
I
right?
thought it was H2O.
It could have been H2CO3. I'm doing it from memory. That looks a little bit better. Okay, so this is carbonic acid. And then the wind blows. This is the blowing of the wind. Okay. And this cloud goes over to Nebraska.
Nebraska.
Nebraska. Idaho.
Okay, maybe not Nebraska. Illinois.
Colorado.
Mississippi.
Okay, we're in Illinois. There's still carbon dioxide in this cloud. So what do we get?
Acid rain.
How many have ever heard of acid rain? It is a thing.
Whenever acid rain
And
is
to a
rain.
point, it's a good thing. And to a point, it's a problem. How many of your parents have ever tried to grow blueberries in the state of Idaho?
Well, my parents wanted to, but they did research and it was not possible.
It's not possible to grow blueberries in the state of Idaho unless those blueberries
Wait.
are on life support the whole time. What do blueberries need?
Acid rain.
Blueberries need acid rain. Yes, they absolutely do. Do we have acid rain?
I am going
No.
to.
So here in Illinois,
Wait, so
yes, Bree, go ahead.
if it's raining acid rain, could you say it's raining my breath? Because you breathe out CO2.
Yeah,
It's
I mean,
raining my
a certain amount of acid in the water is actually okay because we get blueberries.
That's the green blueberry.
Those are some very, very, yes. Okay, so those blueberries aren't quite right. I am limited by the markers, okay?
Why did you draw a smiley face?
Because blueberries are good and I like them. And they can grow blueberries. So a little bit of acid in the water is an okay thing. But if we get too much acid in the water, what starts happening?
We grow blueberries, oh no!
So if we get too much acid in
The
the water,
fishes die.
the fish start dying
Why?
because it's too acidic for them.
No, not the fishies. They're all dead. What about the sharks? That's actually a very good fish.
So those are my dead fish.
What about the sharks?
There are no sharks in Illinois.
Are you
We
sure?
can be quite confident there are no sharks in Illinois. So,
There could be an
Land
aquarium,
sharks.
Mrs. Barlow. That's what
okay, but the aquarium gets its own water and it's all filtered and pretty. But out there in this lake in Illinois, our potato chip factory just killed their fish.
No! I was gonna give those fish some potato chips though.
Potatoes. Wait.
No! Oh no! We can't have fish
We
and
need
chips
to start writing.
because there's no fish.
Actually, we can. Because now it's not illegal to catch dead fish.
So what's the solution?
Not, don't
Somebody
make
wanna
potato chips.
You take out the carbon dioxide.
There are filters and scrubbers that can eliminate some of the carbon dioxide before it enters the atmosphere. There are also cleaner ways of producing energy. There's solar and there's nuclear that don't produce the carbon dioxide. So we do have to be mindful that our actions. Now, do we get acid rain here in Idaho?
No.
No. If we did, then Jen's parents could grow blueberries, and so could I, and I would like that.
Yeah, and then we'd be mad at the other person because they're killing our fish.
Nuclear reactors do not.
Worse though?
Okay, so if they produce a different kind of pollution, and if the
Wait,
government
how do we start with
legalizes
it?
thorium
What's the
reactors,
Did
and
it
you
have
can
a-
recycle the spent rods and have a thorium reaction instead of a uranium reaction, and you'll eventually get to a place where it's not radioactive anymore.
Oh.
So nuclear energy, I mean, everybody's like, it's scary, it's gonna kill us all. It's really not. It's really quite clean. If it's done right. Wind energy is where it's quite clean, except that wind energy you have to have a regular power plant online because it's not reliable, and solar energy is also not reliable. Geothermal energy is pretty reliable. There's a power plant in Idaho Falls that uses the river, and that's pretty reliable. There's also one in Eastern Utah where I went to college. They used to use the energy from the river to produce electricity. So there's different ways to produce electricity, but we have to be mindful that our actions are going to affect other people. So we have to make sure that we're not killing the fish in Illinois. It was a really big problem. I actually did some research on it for a debate thing when I was younger. We're doing better. We're doing a lot better. The technology has happened so that they really scrub these towers before they release the fumes. Yeah.
We should start a potato chip factory because then it won't kill our fish. It'll kill Illinois fish.
But we don't
Just
have a
Illinois
lot of
fish.
fish of our own, and so we kind of get fish from other places.
But we have rainbow trout.
Idaho's not really
That's all
known for
we
their
need.
fish.
Taste the rainbow.
Okay, so pretty much the emissions in the west affect the states in the east, and China and the emissions in Asia affect us. Well, there's
Die,
that too.
people
So-
fish in the
So
west.
we have to be mindful of it.
Die,
Look,
wicked
we're gonna
fish in
play
the west.
today. We're gonna play with
I know, we can fish in the east. We can fish
Hang on, be quiet, guys. So we're gonna do some experiments today, where you're gonna have a little baby cup. It would be really helpful if you would be quiet, please. So if you have a little baby cup of universal indicator solution inside a bigger cup of seltzer water. I got seltzer water this time instead of club soda because they were out of club soda because everybody bought all the club soda for the Super Bowl. So, but seltzer water is the same thing. And then because they want to make their mixed beverages with the club soda for the Super Bowl. And then you put a lid on top and it traps the carbon dioxide, and the carbon dioxide gets into the universal indicator solution that way. You'll see, and I can help you if you need it, and I'll do it for the people at home if you can't do it at home. So, does anybody have any questions on any of this stuff? This is one of my favorites, though. Isn't that so cool? Thing is, there's nothing.
Kind of gross, but yeah.
Kind of gross. There's nothing in my breath that I can do to make that turn back green.
Oh.
we can
What
have
if you-
sodium carbonate.
What if you like clean your mouth with baking soda?
It's my breath from my lungs.
But
If I-
What if you ate baking soda?
What if you inhale baking soda?
Yeah, you're like,
Okay, you know what I can just do? You guys want to see this? I can just add tap water.
does tap water have?
Tap water is quite basic.
Why?
Yeah, it has like
This is calcium.
Red again.
There we go.
Make it
it's
red
still
again.
too green.
Still too green.
We need to have it
There we
green.
go.
It's still too green.
And then
Oh no, not again.
Stop.
Ah, it's taking so long.
There's
Okay,
more.
We have to say "ah" the whole time.
I don't know if I'll be able to get it to go before again. Anyway, that's a fun one.
Okay.
Any questions, Sophie?
No, I'm good.
Awesome. Any questions from any of you that Sophie might like to hear? All right. See ya.
Why are we
with me.